So if we go back to the example of or the general principle of trying to make machine learning boring, going by that principle, we want to hide as much of the underlying model as possible. And so I think a good ML powered user experience should just focus on the benefits to the user and not exactly what the model does or how the model does it. And I think most of the time, if you take that approach, you probably won't go wrong. And so it's true, ML models might have all these a ton of parameters. And so I think a good thing is, and this is just a UX research strategy, where you want to focus on just, let's say, the top 20% of important things the user needs to know. And most users will fall within that bracket, and every other thing you can hide under some sort of abstraction and give users the opportunity to dig in. And so the opposite of that would be letting the user set the temperature of the model, the maximum sequence length. I don't know. Do I use BERT or distilled BERT? All that stuff. Like the user doesn't need to know, right? So most of the users, there's a basic model that will work well for all of them. There's some basic temperature setting that's good for them. So you find out what that thing is. You probably need some user research to find out what those nice, good base parameters are. And then you just focus on the providing value. So this is my thought. However, there are times when you want to do a bit better than that. And so that's when we start going into medium or high stakes environments. So where the output of the model is sort of important. And so one important thing there is to give some measure of the model's confidence, or, just offer the user some additional information such that they can make better decisions. And so, for example, if I was using an app that was going to tell me if I had a skin condition or not, I want to know, is this model confident to this thing, or is it not confident? And so also when you build the system like that, the choice of model to use kind of matters. You want models that are Bayesian, like they can output principal measures of uncertainties. So neural networks typically, they will offer confidence values, but this confidence values typically are just some softmax. These are not true probabilities. And so you want to do your best to, if possible, offer true probabilities that really quantify the uncertainty of the model. And also the usual numbers. You show, okay, 15% accuracy, 87% accuracy. Maybe not, because users might struggle to really figure out what the numbers mean. So maybe you want to do things like very confident, medium confidence, low confidence, that sort of thing.